Well, now let's talk about what to do if you have two qualitative variables and you want to find out if there is any relationship between these two qualitative variables in a way that you did also with quantitative variables, for example, computing correlation, making simple linear regression, and so on and so forth. Apparently, in this case, you cannot use the statistics, the methods that we have learned for numeric variables. So we have to learn new. First of all, the relationship between two qualitative variables, we will call it association. Strictly speaking, association, this term also works for the numeric, so it's a more general term. So association, it means any relationship between any two variables. So strictly speaking, correlation, it's a particular case of association. Okay. So two variables are associated if changing value of one variable results in a change in the distribution of the other variable, right? And then you can think about association as an analog of correlation, but for qualitative data. However, as I said, association is a more general term. Okay. One of the first steps to define association is construction of a contingency table. What is a contingency table? Sometimes it's also called cross table. The idea of contingency table is as follows. It's a table that looks like this. For example, the rows are all categories that you have in variable A. So you can see you have R categories here. Then the columns are all categories that you have in variable B, in the qualitative variable B. So you have C categories, C different levels, C different categories. And then this part of the table, it's all observations which have, for example, this category and this category at the same time. So it's a number of observations where variable A had the category 2 and variable B had the category 1. Okay, so strictly speaking, these are all observed combinations of the categories of the two variables. And then in order to make a contingency table, you simply add a row where you simply sum up all the columns, and you add a column where you sum up all the rows, and then finally here you will have n. This is the total number of observations. So that's what contingency table is. Let me show you an example. I will still use the survey data. So you can repeat all these calculations also yourself, and that's what I recommend you to do. You remember we used table in order to get frequencies and then calculate proportions. For example, if you applied function table in R to a column soda, here I assume that D, it's a data frame that you read from the survey data, from the Excel file with survey data. We will get this table, the frequency table, right? So how many observations, how many students in this case selected Coke, and then how many students selected Pepsi. So I can make it like this, so you can see that this is the frequency and this is the proportion. Okay. I can also do it for fast food, for example, right? So in this case, I have 3 categories. So therefore, I have 3 different frequencies. And again, I can combine them together in order to make a frequency table. And in this case, it's a frequency and proportion table. Okay. What I want to do now, I want to make a similar table, but for 2 variables. So I want to show frequencies for all combinations of these 2 and these 3 categories. So it means that my table will have 6 different elements because we have 6 different combinations. And in R, you can do it using the same function table. You just need to provide 2 categorical variables as 2 arguments. And that's exactly what you get. So you can see this is the frequency table for all combinations. For example, you can see that 20, what means 20? It means it's 20 students who prefer Coke over Pepsi, and they also selected Sunset Boulevard as their preferable fast food restaurant. Okay. So this can be used to make a contingency table because this part of contingency table is exactly what we get using the function table. We call it observed frequencies. So you can see these are all combinations. And then you simply take a sum of every column here. You can see sum of every row here. And this is exactly n. This is the number of observations we have in total. Okay. Contingency table can be visualized in a similar way as you did for the frequency tables by using bar plots. Okay. So for example, these are bar plots I made for the frequencies that I computed before for combinations of the fast food restaurants and the preferences in soda. And then you can see that, for example, if you just run bar plot like this, you can see that the bars are stacked, right? So you can see that, for example, this is Coke. This is Coke. I didn't add a legend. And this is Pepsi. And this is Pepsi. And then you can see, for example, so this is smaller than here, and this is larger than this one, right? So you can kind of see this information already. But if you write also additional argument beside equal to true, then you will see this every contribution as 2 bars, right? So you can see, for example, this is Coke, this is Coke, this is Pepsi, this is Coke, this is Pepsi, and this is Coke, this is Pepsi. So I think that this way is even better actually, because it shows you clearly the relationship between, for example, number of Cokes ordered in different restaurants, right? You can see that in this case I have 3 pairs of bars. It means that it takes every column of your contingency table. So this will be 1 set of bars, this will be 2nd set of bars, this will be 3rd set of bars. So you will see as many set of bars as many columns you have. What if you want to do the other way around? Well, in this case, you just need to transpose your frequency table. So you can see this little t here, function t. It swapped the rows and columns. So columns become rows and rows become columns. So in this case, you can see I have 2 categories. It's Coke and Pepsi. And then I have inside each, this is the Sunset Boulevard, this is McDonald's, and this is Burger King, and so on. And then similar here, you can see that it's just beside. I just add this attribute beside. And then you can see every restaurant as a separate bar. And then we have two sets of bars, one for Coke and one for Pepsi. Okay. Of course, as anything in R, we can make it looking really, really nice. For example, like this. You can see it's the same bar plot as I made before, but I also added brand colors for Coke and Pepsi. I also added legend. That's very handy. And I also added the frequencies as labels, right? And then this is the code. First of all, I Google for these colors. So what is a brand color for Coke? What is a brand color for Pepsi? And I selected one of those because they have several ones. So this is red Coke. This is blue for Pepsi. And then I combine them together into a vector and save to a variable call. Then I made a bar plot. For frequency tables, I say beside equal to true. So it's each drink has a separate column. I use columns that I saved before. I use white border, so it means you can see that this border is white indeed. And then this is the manually defined limits for y-axis, so between 0 and 500, and 50, sorry. After that, you can see I also saved the position of these middle points of every bar. I saved it to a variable p. After that, I use function legend to show the legend. I say it's top left, so you can see it's indeed in top left, right, of the plot. This is the names of the labels, Coke and Pepsi. This is the colors. It's the same colors as I defined before. This is the point character 15. It's just a square, a fillet square, and that's exactly what you see in the legend. And then finally, I say don't show the box around this legend. In this case, I simply say color of the box NA. It means not available. So don't show any box, so to speak. So no colors. After that, I also add the text. I use the previously saved positions of the middle points of the bars. The frequency table. I also show frequencies as the labels. Position 3 means on top of the bar. Dark gray, and this is the size of the labels. So you can see that it's like Lego, right? So I used to say that quite often. You can make any plots you want. Okay. So this is how to summarize and also how to visualize association. But of course, we need to also to quantify this association. Can we say it's a strong association or not strong? Is it significant or not significant, and so on? It means that we need to run a test. There are several tests you can use to define how strong the association is. I'll show you 2 of those, the relative risk and the chi-square test for association, and we will start with relative risk in the next video.